Hello everyone, welcome to my YouTube channel. I hope you all are doing well. I am going to explain one shortcut trick in order to check the differentiability of the function. We are going to do it graphically. If you like my video, please do subscribe my channel. Let us first see what is the definition for differentiability. A function is said to be differentiable at a point if it has a derivative there, or you can say that if the derivative exists, the function is said to be differentiable. Limit definition says that a function is differentiable at point x if limit h tending to 0 f of x plus h minus f of x divided by h exists. That is, if the limit is existing at that point, then the function will be differentiable. Now, how to check with the help of shortcut whether the function is differentiable or not at a particular point. Then for that, first situation where the function fails to be differentiable is the discontinuity of the graph. As we are having the floor and ceiling functions, or you can say greatest integer functions, the floor function is the greatest integer less than or equal to x, and the ceiling function is greatest integer greater than or equal to x. Suppose we have a number minus 1.1 and you want to find its floor function, then you have to just see the number line. Suppose you are here and you just move to the integer left. So because we want less than or equal to x, it is 1.1 something here, so the integer which is on left will be minus 2 here. So floor function is greatest integer less than or equal to x, and the ceiling function will be the greatest integer greater than or equal to x, which is next to x, that is minus 1. So I hope the definitions for floor and ceiling functions are clear, and you can easily plot the graphs for the floor and ceiling functions. As you can see, there is jump or the discontinuity at each integral point. So, and you can observe one more thing, that this is left filled and the ceiling function is right filled. The floor function is having dark dots on the left hand side of the stair, and the ceiling function is having dark dot on the right hand side, because we are moving towards right in the ceiling function, and in floor function we are moving towards left. So the floor and ceiling functions are not differentiable directly by looking at the graph, we can say, because these are discontinuous at integral points. One more example is the fractional part function, which is x minus, the fractional part function is x minus box of x, again the number minus the greatest integer function, and the values will always lie between 0 and 1. So here is your graph. The value of the function will always lie between 0 and 1. Again, there are discontinuity points at every integral point. So this function will also be not differentiable. Next situation is when the graph has sharp corners at the points. As we can see for mod x, the modulus function, which states it will be the value will be equal to x for x positive and it will be negative of x for x negative. So we can easily plot the graph, and you will get a corner point here. So the graph is having a sharp corner at this point. So at x is equals to 0, the graph will not be, the function will not be differentiable. Next is the graph is smooth, but it does not, it is having vertical tangents. Vertical tangents are again creating problems. Why? Vertical tangents means the curve is having infinite slope and the function is again not differentiable because m will become either infinity, plus infinity or minus infinity. So the graph is again not differentiable, or the function is not differentiable. You can see vertical tangent here. This is your vertical tangent at this point x is equals to 0, because what is the derivative? It is denoting the function's derivative is denoting the differentiability only, and if the derivative is infinite, that means it is not existing. So tangent denotes that function is not differentiable. Let me again summarize. If the cusp or corner is there, or sharp turns are there, then the function is not differentiable. If we have points of discontinuity, then again function is not differentiable. If we have vertical tangents, then again the function is not differentiable. And one more thing, if the function is not defined at that point, then also the function is not differentiable. I hope you like the video. Thank you so much for watching the video.